So let's match whether we are sharing correct information. How? Cryptographically, to make sure that you are able to validate information at two ends without the need to share. Someone says, "Are you 18?" And I say, "Okay, take my voter ID." No, let's do something cryptographic, which we in the world of privacy say zero knowledge proof. Right? Welcome to my YouTube channel where you daily see new content on data privacy. And as I said, we are talking about zero knowledge proof. The person handling the data just needs a validation that he has the correct data. He just does not need the data again to validate. Right? Data does not need to be shared again to prove the authenticity of data. So you create necessary exposure, or rather unnecessary exposure of your data just because you want to prove that your data is correct. Startups handling KYC, credentials, access checks, they all face such difficulties. So what is zero knowledge proof? Zero knowledge proof is that you have my information and you want to validate it. I'll send you a cryptographic method or a cryptographic proof whether the information is correct or not. Sharing from one party to another, first party needs to prove the correctness with data sharing. For example, you can prove that you are 18, but you don't need to share your date of birth or any of your personal IDs to prove that you are 18. How? So the prover has a code, and the receiver challenges the prover to prove that the information is correct. So prover, instead of sending the information again, or a documented proof, as I said, like your date of birth, he sends that code. And if the codes match, now the person having the information, the verifier, he knows that the information is correct. And if the codes don't match, then there is a possibility of it being an incorrect information. Now you would say that in that case you will share the information. But yes, at the first step, if it works well at the first step, I'm not sharing anything. The prover responds mathematically and it goes on to the next level. The information can be correct only if the secret has been shared properly. Verifier can claim or confirm the validity of the information, and there is no information exchange in this case. So what are the various types of zero knowledge proof? Interactive. The prover talks, and talks does not mean he's making calls or something. Both of them are exchanging cryptographic online messages for verifying the information. They identify and verify the information. In the non-interactive one, it's a simple cryptographic message as a proof. One-time answer from the prover that this is the information. For example, blockchains, smart contracts. The prover says this is it. You like it? Good. You don't like it? Very good. Your choice. But I'm not revealing the data again to you. For example, the KYCs. You want to identify the verifications? Well, a must. Aadhaar card, access controls. I don't need to give you passwords again and again. I've given you the MFAs. You handle your MFAs. Blockchain and Web3, they both work on cryptographic methods. And normal audits with respect to compliance. All data sets are not shared. Only the related information, how it can match, is shared. The advantage of using a zero knowledge proof or cryptographic method includes preventing leakage of information, enabling trust without a transparency trade-off, right? Trust stays there. It reduces regulatory exposure of information, and it's very, very essential to be a part of the privacy by design architecture being followed by an organization. Very, very important thing in that. As a limitation, it needs a lot of computation just to make sure that the information is not retrievable from the cryptographic code. It needs a lot of computational intensive information, overheads, resources, therefore cost. It makes it complex also sometimes to implement it, and it requires strong cryptographic expertise. Key takeaways: zero knowledge proofs redefine trust. You prove your thing to me without even showing it to me. It's a perfect fit for privacy first startups. That's it. Two important things: not sharing my information again, I'm just sharing a code that can help you identify whether the information you have is correct or not. Right? A sort of a MFA example where It's more for authentication, not exactly for sharing information. But if I send you a OTP and that matches the OTP in the authentication app, then it means that you are allowed to access it. Similar cryptographic things for the personal information. Prove the data without showing or sharing the data again. I hope you like the content of the video. Please press the bell and the like icon. Subscribe to my YouTube channel to stay updated on privacy information and share your feedback in the comment section. Thank you.